All right, today we are looking at lesson 49. Introduction to solids. What is a solid? Oh, that's a science term, looking at liquid, gas, and solid. In geometry, a solid is a three-dimensional figure that can have flat or curved surfaces. Surfaces. All right, looking at polyhedron. You've probably not heard this term before. Any closed three-dimensional figure formed by four or more polygons that intersect only at their edges. A cone. You know what a cone is? It's a three-dimensional figure with a circular base and a curved lateral face that comes to a point. You know what a cylinder is? It's a three-dimensional figure with two parallel circular bases. You're close. And what else? A curved lateral surface that connects the bases. Lateral surface that connects the bases. It wouldn't be a cylinder anymore. I don't know what that would be. I don't know how we'd find the area or the surface area or the volume or anything. I guess it would be like a trapezoidal kind of thing. Well, if you think about it like a cylinder, like if you open it up, it makes a rectangle. So if you had one that was like this and you open it up, it'd be a trapezoid. If you if you cut it at the lowest point, it'd look kind of like a trapezoid. Oh wait, and then it'd go back down. Well, I don't know. They're not going to give you one like that. I don't know. I guess you could find the volume and then take out like the part that's cut off. I don't know how though. We do it like later. We'll do a lesson where if you have like this is a cone, and then they cut off this part. We know how to, Well, we'll learn how to do that, but not at an angle. Yeah, so I don't know. I don't know how to do that. I'm sure it can be done. I just don't know how off the top of my head. All right, looking at a sphere. Y'all know what a sphere is? It is a set of points in space that are a fixed distance from a given point called the center of the sphere. That's my given point. If I go out this far, it makes a circle, right? It's only on one plane. But if I can go in any direction, I can go out this far, like all of this is going to make a sphere. Does that make sense? Because it's a circle that can be like moved around that same point. So take it and you can like rotate it. Does that make sense? Okay. All right, what is that? Sphere. What is that? A polyhedron. Okay. What is that? And that one? Don't you feel like you're back in like second grade? Yeah. Okay, so now that you know what all of that is, we've got a little bit more that should be mostly review, and then we'll get into the actual like geometry part of it. But they want to make sure that you know all the terms before they like start using them. I would draw that figure. It doesn't have to be great, but just so that if you need to, you can point to what's the face, vertex, edge, face, lateral face, that sort of thing. Doesn't have to be a very pretty picture. Hexagonal prism. Yes, that is the name of it. And we will do that in this lesson. We'll practice naming some of them. Do what? All right, so a face, each flat surface of a polyhedron. Surface of a polyhedron. These are all only for polyhedrons. Well, more specifically for polyhedrons. They can be applied to the other ones, but we're looking at polyhedrons in specific right now. How many faces does that figure have? Where did you get the 8? 2 bases and then 6 sides. Make sense? Okay. Edge. It's the segment that is the intersection of 2 faces of a solid. Do you understand what an edge is? Like, if my textbook is a solid, which it is, this is an edge, this is an edge, this is an edge. Does that make sense? Okay. How many edges would that figure have? Count them. 1, 2, 3, 4, 5, 6, right? And then 6 more at the base. Where'd they get 18 then? 1, 2, 3, 4, 5, 6. So 18 in total. Huh? Yes. Well, kind of. We'll get to the formula in a second. All right, vertex. The point of intersection of 3 or more faces of the figure. So see if you can count up how many vertices are in that figure. Where are those? 1, 2, 3, 4, 5, 6. Right? 6 and 6 gives you 12. Does that make sense? Okay. A base. Do you know what is a base? One of the two congruent parallel faces of the figure. Figure. No, faces of the figure, sorry. So how many faces do we have? 2. And where are they? The top and the bottom. How many bases would we have in a cone? 1. How many bases do we have in a pyramid? 1. What about in a cylinder? 2. Okay. A lateral face. A face of a prism that is not a base. Yes, that is the definition. A face of a prism that is not a base. So it's either a base or it's not. If it's not a base, it's a lateral face. How many lateral faces do we have in this figure? 6 of them. In this case, they are all vertical, but in a pyramid, are the lateral faces vertical? They're slanted, and that's why you can't say the vertical faces. Does that make sense? You could, yes. Yeah. You could do that, but they're still, you could turn it over, but they're still going to call these two the bases, or the two that are parallel. What? The bases are what? Yeah, the bases are these two. And even if you flip it over, it's still going to be the two. They're not going to change them. All right, a prism. A type of polyhedron formed by 2 parallel congruent polygonal bases connected by lateral faces that are parallelograms. A pyramid is a type of polyhedron formed formed by a polygonal base and triangular lateral faces that meet at a common vertex. So a polyhedron is basically, you know, your shapes that you learned at the beginning, except like triangle, quadrilateral, pentagon, hexagon, octagon, that kind of thing. It's a shape formed by those. More specifically, a prism or a pyramid. A prism is rectangles and parallelograms. A pyramid is one of those bases, 3, 4, 5, 6, 7, 8, etc. sided figure, and then triangles that all meet up. Those are the two types of polyhedrons that there are. Does that make sense? You've always learned just prism and pyramid, but they're actually related because they are the only two that are made up of like 3, 4, 5, 6, 7, 8 sided figures. Not circles, basically. Like a cone and a cylinder are both have a circle for one face, and then a sphere, it's like not made up of any shape. It's its own shape. Does that make sense? So that's how those two are related. The last one, cube. You know what a cube is? It's the special name for a prism with 6 square faces. All right, last definition. The diagonal of a polyhedron segment whose endpoints are the vertices of two different faces of a polyhedron. Any questions on the definition so far? Okay. So we want to classify each polyhedra. Plural of polyhedron, polyhedra. How would I classify that? This is a hexagon, and it's a prism, right? It's a hexagonal prism. Does that make sense? What about this? Triangular prism?
Teachers, pardon the interruption. If you are 18 years or older, you can go to the gym lobby and do the body assessment test. You must be 18 years or older. Thank you.
At first I thought they were saying teachers, if you are, but they're saying, excuse me, teachers, to the students, if you are 18. I was like, you have to be 21 to be a teacher. All right, looking at that one, what would it be? It is a pyramid. You can say pentagonal or pentagonal, either one. When you write it, it's going to be spelled the same. Penta, like as in penta, and then gonal. So however you pronounce it, it really doesn't matter. Yes, it is a triangular pyramid. Does that make sense? Okay, so when it says classify, it means like what would be its name. Don't just say, oh, it's a prism. What type of prism? Hate that bell. What type of pyramid is it? Okay. All right. Classify the polyhedron, assuming all of the angles of the base are congruent. How would you classify it? Hexagonal pyramid. Is it a regular polyhedron? It is a polyhedron, but it is not regular. However, it is a regular hexagon for the base. Does that make sense? It's not a regular polyhedron, but it's just a regular hexagon for its base. Does that make sense? Okay. How many edges does it have? Has 12, 6 on the bottom and 6 around. How many vertices does it have? 6 at the bottom and 1 up top. And then how many faces? Does that make sense? Any questions there? Okay. Name the diagonal. Nope, not BA. Not BG. Look back at definition of a diagonal. Using the points that they give you, because they're from a vertice to another vertice. No. I'm going to draw that one in. CF. That's just a diagonal of the hexagon. Is it a diagonal of the figure? Did it leave that face? It's still on the same face, so that's not a diagonal of the figure. That one. Is that a diagonal of the figure? Because it didn't leave the face. It stayed on the same one. Using the points they give you. No ideas? There are none. You can't make a diagonal on this one. Does that make sense? Any pyramid will not have a diagonal. It has to be from a vertice. Go from one vertice to another. Does that make sense? That's why you can't add a point, because all the vertices have a point already. Any questions there? Well, sometimes they'll ask you that. Name the diagonal. Well, there isn't one. So you'd say, there is no diagonal to name. I didn't hear you. I'm sorry. Yes, you should. All right. Euler's formula. This is the formula that relates edges, vertices, and faces. V stands for vertice, E stands for edges, and F stands for faces. Makes sense, right? V minus E plus F equals 2. This is true for any polyhedron, so not for a sphere, cone, or cylinder. Polyhedrons.
Part of the format is all people saying stuff like
Oh yes, Euler has a lot of other stuff. I think he's the one that came up with this formula. I think. Where you use the formula, I don't remember, but it's just a cool formula because it uses E, pi, and I. I think he's the one that came up with that. No. That's just a random math fact. Do what? All right, how many edges does a polyhedron with 16 vertices and 10 faces have? What would you have to do? Okay. Plug it into your formula. What are you going to get for E? $24? Does that make sense? Do you need to learn this formula? Yes. If you do not learn this formula, when you get to these problems, you're probably going to miss them. Does that make sense? Huh? Yeah. I mean, you could possibly draw the figure, but it's so easy if you just use this formula. Okay. Last problem. They start with a square. They're cutting it to make a diamond. And they cut it over and over and over and over. Oh, what? Some jewelry store. I don't even know the name of it. Like they boasted about this. Like they have a name for it, and it's like a special type of cut. You know how like these are princess cuts because they're squares. They have some that are round. They have some that are emerald, oval, etc. Like they have different names for them. They have a special cut. I mean, it's like a circle or a square, but it's a special name of it because it's cut differently. It has like 102 cuts. I don't know. Like that's how, like they cut it. I mean, well, for these even, you cut them a lot. That's like why they sparkle. Like the light reflects out. Anyway, so they start with like just this thing, and then they start making cuts on it. I don't know what they do. But this is the first cut. Right here. And then they do the second cut. And then they ask, what is the number of faces, vertices, and edges in the third step? Do they have the third step shown? No. They only showed you, they showed you the beginning, and then after step 1, after step 2. If you want to draw the step 3 and then figure it out, you can. Or if you can just do it not drawing it out, doesn't matter to me. Whatever works better for you. I don't know. Oh, there's not really a trick. You just gotta count them. Okay. I know how to do it in calculus. I know how to do it for calculus. But I don't know how to do it. It's not a formula. Like, you use calculus to do it, but I don't know how to do it. Like, I don't know of a formula for it. All right, how many faces would there be? You start with 6, right? And then you add a face, you add another face, and you add another face. Does that make sense? Okay. What about the vertices? How many vertices do you start with? 1, 2, 3, 4, 5, 6, 7, 8. And then you take out 1 and add 3, right? So really you added 2. So 8, 9, 10, 11, 12, and then 13, 14. Make sense? How many edges? How many do you start with? 12, and then you add 3. So 15, 16, 17, 18, 19, 20, 21. Does that make sense? So after I get those 3, I can use my formula to figure out whether I did it correctly or whether I was close. 14 minus 21 plus 9. So it works. But that doesn't necessarily mean I did it correctly. I could have miscounted on 2 of them. But if you feel like you at least did 2 of them correctly, then your third one was probably right. Does that make sense? Any questions there? Okay. Your bench